Coming to you at your leisure from Third Wave Arcade and Hard Work Party Studios, this is Third Wave Arcade, how I make things in TouchDesigner in 2025. Hi, I'm Noah and I have a mustache now. It's been a while since our last video and I'm sorry about that. I know I promised you a video about multiplayer, multi-camera, infrared, real-time markerless motion capture, and I'm still working on that video. I promise you I am. The ducks are in a row. Now all I have to do is shoot the fish in the barrel. I gotta be honest, I've done a thing with this channel already after one video that I keep promising myself I won't do, which is going kind of ham, making a very high production video. It's a lot of work. I feel like I set a bar at a level where when I go to work on the next video, I feel kind of overwhelmed. Not to put that on you, but it's kind of your fault, but it's okay. One way that I'm gonna work on that and try to get more videos out is to just toss off videos, not half-ass it, but like fewer asses. This video, by very popular request, is gonna be about how I build applications in TouchDesigner in 2025. I mean, it's right there in the title of the video, but also state machines, or a state-driven application with a finite state machine in its heart. And it's gonna be about the use of Python extensions, which is something that you know I yammer on about with quite some frequency. What I'm gonna do is just walk you through an application that if you work professionally as a TouchDesigner developer, you've probably had to make 1,000 times. And I was asked to make one just recently by some friends. So the request was a photo booth. The thing needs to be able to record people doing something with a camera and then play it back, show it to them, follow that up with a CTA, a call to action, some kind of thing that tells them where to go find their video or tells them to go visit some website, normally some kind of marketing related thing. Okay. It's going to start in some kind of a track mode on some kind of input. Something is going to, keyboard press or Stream Deck or something is going to tell it to go. On some kind of input, record from a single camera to a file on disk. While recording, show the camera on a foldback screen so the visitors can see themselves while they're recording. Typical photo booth stuff. While recording, play media for the background LED screen. There was going to be a LED screen behind the person. Again, common photo booth thing. Put them in a background of some kind in camera. When the recording finishes, play back the recorded clip on the foldback screen, right? Normal thing. Here's your video. Good. And then when the playback finishes, show a call to action of some kind. Go to our website, whatever. And when the call to action finishes, go back to the attract screen. Pretty straightforward stuff. And we're looking at how I organize the top level of all TouchDesigner applications. For one, everything is a base for the most part, except things that need to have a display. Those are containers. Everything that needs to be told what to do has an extension. Oh yeah, you can look at the top level of the application as a table of contents and see right away when you've arrived where everything lives. Everything's got its boundaries. It doesn't work outside those boundaries. And just about everything is ignorant of the state of the application except the base I normally call state. State is where things get told what to do. It's where the entire application drives itself forward. State itself doesn't do any communication, doesn't write to databases, doesn't talk to hardware, doesn't, grab cameras, doesn't record disk. All those things happen in specialized components, bases, that are told what to do by state via their Python extensions. And I use Python for just about everything that drives business logic forward in the application. And I do that because it makes it so I can read the entire application in an IDE, for the most part. I use ops very sparingly. So if I start popping into these things, you're gonna see they have just a few ops, typically only what is required to do their high performance business. So, things tops, chops do best, but I almost never use DATs for anything except text. So starting at the very high level, just kind of look at how I set up an application. I always have a BAT and DAT folder in every project. DATs are where all my Python extensions go and where I keep my settings. I have a log folder that's made by my log component. It's just logging all the time. It's logging what's going on, with the performance of the application. Everything prints in here and says, what it's been up to, and the application is constantly clocking its own performance metrics. README if I'm going to give the file to someone else, and I have a git ignore that ignores a whole bunch of stuff. In the BAT folder, I have a batch file, and that batch file is the thing that I use to run my application. I run my application by setting an environment variable, typically called node, that tells it which machine I'm running on, so I can make a distinction between my workstation and the production machine. And I normally open my IDE of choice in the app project folder in the project level, and then I run the application in a specific version of TouchDesigner because I can't be goofing around just letting it open in any old version of TouchDesigner. I've developed this to run in 12,000 for some reason. That's what it was out at the time, and so that's what it runs in. So that means when I want to run the application, I go into my bat folder and I'm going to double click this and it's going to run my specific version of TouchDesigner. And at the same time, because I have this line that says start cursor dot back in the root level of the project, it will run cursor from this context. And then if I go into cursor, you'll see that I have the root level of the application open here. I have that batch file. I can edit it here. I probably should just be doing that. I have my settings here, which we'll look at in a moment. And I have all my extensions right here. And I spend most of my time when I'm building in TouchDesigner really looking at this, not looking at the TouchDesigner interface, because I'm not in nodes. I'm just not into nodes. The first thing that happens in the program, I only have one execute dat set to onStart. All my onStart does is it runs startup. Sometimes it delays startup if there's like a funky condition with the bootstrapping the program, but don't worry about that for the moment. It's commented out. So we're gonna run startup here. Startup runs startup over here, and the first thing startup does is it adds dependencies to path from the dependency folder and the Python folder within that. But this is to add external Python libraries to your Python path in TouchDesigner, which is this guy right here. So we're going to add dependencies to path, and then we're going to run config settings on the settings op. All of these all caps op.blank calls here are using the global operator shortcut on the op level. So what that does is it allows you to summon this operator via op dot and then the name of the global op shortcut. You can have a different name from within the operator. So if you set this to, I don't know, settings parent or something, inside of settings, then I could say parent dot settings parent and summon this op. And you might want to have different names for different reasons in those places, but I just do the same thing everywhere. And so when I say op dot settings anywhere in my program, that gets me to settings. And from there, I can call directly into extension members, these methods and members in the class settings extension. Now, if at this point you're thinking, what's an extension? That's a good question. Why would I want one? That one I'm gonna answer. How do I create an extension? You will see me do that a little bit later, but that's not the point of this video. Just to preface this, this is not gonna be a video about how do I use extensions. It's more about why I use extensions. This video is gonna be about overall application architecture and how you can use extensions to make your applications legible, maintainable, and things that you can collaborate on with other developers, because Python code that comes out of using extensions is diffable. This is code that you can merge in a Git repository or other version control, unlike TouchDesigner, which at the moment is encoded as a binary. We covered this in the last video. I'm using global op shortcuts to refer to these things. The second thing that happens in my application is I call into extensions and I call config settings. I'm gonna go back to the top and I'm just gonna like run my project from the top here. I'm gonna go to startup. I'm gonna say op startup.startup. I call startup. The first thing that happens is startup runs and it calls config settings. I go over to settings. Now config settings is gonna run. It's going to check what the environment variable node. Now, if you remember, back in our batch file, we set the environment variable to be HWP, hard work party. What this does is it loads that environment variable. If there isn't one, it's probably because we ran this from a Mac, and I normally don't bother setting up a shell script and blah, blah, blah if I just want to work on the Mac for a second. So it just assumes I'm on hard work party Mac. But otherwise, it's going to take that node value, that string, and it's going to use that over and over again to look into this settings table, self.node settings. It's going to look for the row by the name of my node, which is HWP, and then it's going to pull out values in certain columns. So let's go over and look at what that looks like in TouchDesigner. So we have two columns in this particular setup. We're going to look for hard work party here. We're going to grab the asset path and set that to this asset path here, which is a dependable property. So that means anywhere inside the program, if I say op.settings.asset path, I get the path to where I'm storing assets for this. In production, you can have that be a different value. Same thing with the record path, that could be a different value. So then if I'm gonna go load an asset, let's say, I might go into my assets folder. Now this folder is here, so let's go find this. Here we are. So I'm just gonna grab this air horn asset here. There you go. Now we got this air horn sound in here. I'm just gonna grab the name of the actual asset, and then everything leading up to that, this is my best practice for this, is to say pop.settings.assetPath, and I'm just gonna create an F string that parses that out, adds a slash, adds the air horn, sheboygan. So now, if I'm in prod and I've launched with a batch script where it set the node to prod, it will insert the asset path used on the prod box. Or if I'm another developer, I just add another row to this, and I say I'm Bob the developer, and I'm gonna put my own asset path. And you can have a separate path for anything you want, or set any setting you want in here. So I might put in another setting, and I frequently do this in projects, where I would add a column for resolution X and resolution Y. And maybe in dev, I'm working at 1080 because I don't have a crazy GPU, but in prod, maybe I've got UHD in production. And so I might load these in the same way that I loaded my asset path here and my record path. And this is gonna execute on startup, and then I have access to these members. I would need to create properties for those, but I have access to these things, and I would refer to them everywhere, you know, I'm setting the resolution of, let's say, my renders or my output or whatever. And that way you can set these things at runtime and have different boxes have different behaviors contextually. Especially with the asset path, this is a best practice. Even if it's just you working alone on a project, as you go through and you refer to assets in your project, you load assets and stuff like that, you can make them all relative to this variable asset path. And that's gonna result in a portability for your application where you can move your code, which is probably gonna be megabytes, and move your assets, which could be gigabytes, separately from one another. As I told you, at the very top of everything, this state object is driving the show. Go check out our last video about how the timer chop, in my opinion, is not an appropriate state machine around which to build an application. All I use the timer chop for is timekeeping, and in fact, it could easily be replaced by a little bit of Python code. I may start doing that in the future. I do kind of like being able to look at the timer chop as I'm bootstrapping up the application, so I keep it for now. Let's look at my state extension. State extension, when it starts up, has the boilerplate set its owner comp. I've made a state machine by hand here, so I'm just enumerating a number of valid states that the state machine could be in, and when I go to set states, I make sure that I'm being asked for a valid state. And then it sets its public member state to attract at the beginning. And I'm using strings here. You could be using an enum. You could be a little more specific about this. You could use a custom type, data class, something like that. This is all I need for the moment because I wrote this application in about 2.5 hours and I was on the clock for the client. I was trying to make it nice and quick. The most important method that you need to know in this state machine that I've built here is set state. And set state accepts a state, which is a string. If it is a valid state, all it does is set its own state to state. Otherwise, it logs that it received an invalid state change. And then it calls handle state change, and it's going to actually do something as we enter the new state. Now, in a more full-featured state machine, this particular callback, because we've already set the state, might be considered on enter state or something like that, because it's firing as we arrive into the state change, not before we change states. So we're going to call handle state change now. We've gotten a valid state, and we're going to change states. When we enter attract, we do a bunch of stuff. You can see that we're calling the compositing extension to set the source for the LED playback. We're setting the foldback source to the camera. We're setting the capture mode to false. We're not capturing, we're not recording right now. And we're hiding the countdown that was driven by the text comp. Maybe I peeked into one or two of them, but you haven't seen the internals of these comps at the top level. But you can read exactly what happens in my application from state and know how the show is supposed to go. Similarly, I could, if one of these was complex or I was in a crazy rush, have worked with another developer to implement one of these submodules based on a software contract, you know, basically an interface, an API. I could say, I expect your component to have a method called setLEDSource that accepts a string, and these are the valid strings that it can accept. I expect it to have a set foldback source that accepts a string, and these are the valid strings that it accepts. Again, we could be doing enums here or types and be a little more strict. Set a capture mode, accepts a Boolean. Set countdown visible on text, accepts a Boolean, whatever it is. And I can trust that another developer implements this the way that we agreed on, and I can be in charge of state and manage state, and I can read exactly how my application works from the top. Now, just so that we can clear up any mystery about what this might be like, let's go look into comp and look at these methods. Let's look at setLEDSource. SetLEDSource accepts a string, and the two strings that it accepts are capture BG and attract. Yeah, for now we're just passing around strings. All we do in response to that is we set the value of this dependable int. Well, I mean, it's not typed, but this dependable member of comp. I don't really like to use dependable members to drive behavior in my op world inside TouchDesigner because there's kind of a hidden, less than explicit linkage that happens there. You can have some kind of trust about the way dependable members work, about the way they propagate inside the pull TouchDesigner cook chain, but especially when I'm going from Python to TouchDesigner and back, I like to follow the TouchDesigner PEP mantra that explicit is better than implicit, and I like to do everything in my power to make sure that it's really easy, as you saw from my state extension, to read my application like the table of contents of a book. I do the same thing in TouchDesigner that I do in my main kind of business logic part of the application. I try to write things very explicitly in a declarative way, I believe is what they call this kind of programming, where there are as few as possible implicit business logic actions. One example of something that I would really recommend you avoid is using the run method, I guess it is, part of the TDU module. You can say run migrate function, thank you very much, and then you would say delay frames farms 1 billion. That is somehow not unavoidable, but these kind of delayed executions represent a flavor of a type of opacity in the code that I like to avoid at all costs, because these things are throwing state into a context in which it is no longer visible from the places where you would go to do your reading and debugging, your understanding of your application, and that can create nightmares in a more complex application when you start to encounter unpredictability, bugs, etc. I have said before, and I'll say again, that the top 3 most important things in TouchDesigner code to me are legibility, legibility, and legibility, and then after that you have things like performance and stuff like that. That's a luxury that I have because of the type of applications I work on. There come times at which you have to sacrifice legibility in the name of performance, but it's a long way away in the development of almost every application from the beginning, where you should be building for legibility and interpretability and maintainability. You can optimize much, much later in the game and selectively in places where it's worthwhile to you. All of that was by way of explaining that I do use dependable properties to drive business logic to a degree inside the application, but this is one of the kind of only ways that I do it. And what I do is I grab that dependable property, I filter it in order to make a crossfade, and these last, a second or 2 seconds or something, and they're crossfading normally in some kind of switch. Or I have this show capture indicator thing, etc. These are all the same flavors of the same gag. So I do that as kind of a linkage between the parent comp Python code in the class, the extension, and the operator network. But it's pretty explicit. I also consider this to be a misuse of the constant chop. I don't think this is technically what constant chop should do. You could use a script chop if you want to be more explicit about it. It's just a series of indirections to accomplish the same thing. So this is a thing that I do that I'm fine with. I don't hate myself for doing this. It is what it is. Okay, that's just by way of explaining what you can expect to find inside these members that are getting called at the top level. But again, the implementation of these things doesn't actually really matter from the level of the state driving business logic part of the application. Some people call it a maestro or a conductor or a command and control system. I consider it to be the table of contents of my application. This is really all you need to know in order to know how the application works. So if we call it attract, all these things are going to fire. Let's just try it. We haven't seen anything happen in the application yet. This is presentation right here. So these are the 2 screens that are going out. And when we go to present, we have select the LED and select the foldback both from the comp. We would lay these up into a window comp and throw this out, to the screen. I just didn't know what their window arrangement was, but you know how this stuff works. Okay, so if I say op state, set state, and I set it to attract, I think it's already in attract, but let's just be explicit. Boom, we're in attract. And then if I fire countdown, we're gonna run the application here. We start the timer in state. Now we're recording. We get our playback. Great. Buy our thing. That's the CTA. And then we're back. That's the whole loop. I print this stuff to the console so we can see what's going on. But again, we can read this here. At the top, we set the LED source to the capture background, whatever the background is going to be for the video. We make sure the fold back is on the camera. I don't mind repeating things to be explicit in adjacent states, because especially during development, it's very likely that you're going to pop from state to state in a nonlinear way, in a way that is not the way that the application is intended to work. And so if you want to be super sure in every state, be super explicit about the setting, the sub-state of each sub-module in your application. So in Countdown, we set the capture mode to false. We're not recording yet. We start the timer on self. We'll look at that in 1 second. And then we tell text to start the countdown. And again, if you just read through this, you can imagine what all these different things do. We play the capture background from playback. It's just a movie file in. In capture, we start capture. That's a movie file out. We create a file name, which is just this string that we're going to call the file name. We make sure we've got the recording path, and then the full path is the combination of the file name with the recording path. We set the last record path, so we have that because record is going to need that in a moment. We set the movie file out, we hit record. When the timer ends, we get told to stop capturing, we tell it to stop recording, and we return that last record path because we want to hang on to that. So when we call that method, stop capture, the recording path bubbles up to state, and then state tells playback to play that clip path. Why don't we just have capture tell playback what that path is? Well, because that would be an example of coupling and implicit state code logic, whatever, that relies on the implementation of playback and the implementation of capture being aware of one another, and they shouldn't. They have nothing to do with one another. Playback is for playback, capture is for capture. So capture, when it's told to stop capturing, just hands back the file name to state. State could ignore it, but state hangs on to that and uses it to tell playback, play this clip. I could tell playback to play something else, but I'm gonna play the last clip that I recorded. And this bit of logic is now visible at the application business logic controller level, at the conductor, controller, maestro level. And I can, for example, print this here if I want to go like, wait, where did my file go? Or like, why is this behaving funny? Or whatever it is. I want to log that or something like that. So this is a really good illustration, I think, of a simple principle and a very simple application of that principle done in a way that seems irrelevant or unnecessary. But this underlying principle as to why you would do this is very important. If capture were to pass playback the name of this clip, I would need to remember that that's how that works. And if I'm new to the application, I would need to read both of them to understand how that works. If instead this stuff happens up here in the table of contents where everything important happens in the application, I don't know based on stop capture what actually happens in stop capture. I could write my own recorder. I could be streaming from the camera out to Spout, and I could be recording in OBS or something like that. That implementation could change without this top level thing changing at all, and that's fine. But the fact that what replay plays back is this path, is this last clip, should be something that is visible from the top level of the application, because it's something that I might need to understand and debug when I'm revisiting this, as I just did for the first time in a long time. I should be able to go here and read the entire application. And I'm reading you things that I haven't looked at in, I don't know, months or something like that, but I can tell what they are just like you can, because that's the whole point of writing the code this way. Okay, notice that I am pulling from settings the replay duration seconds, the capture duration seconds, the countdown duration seconds, all of these states that have a timed component to them. A track just goes on forever, but these states have a time component to them. In this case, in this application, I've chosen to bubble those up as pars so that when the client got on site and they wanted to commission this photo booth, they could very easily change these, just say like, oh, it feels like the recording should be a little bit longer, or it feels like the CTA is too long, or whatever it is. Just change them right here, and the next time it runs, it'll be fine. I could, if, this were something where maybe those numbers would be different in different locations, add those as columns in my settings table so that you could have those values be different for location A, and then in the next part of the tour, we know people are going to want to record longer videos, whatever it is. But I set them as pars here, and so we're going to reference those pars absolutely every time that we fire these, so that the next time it runs, that new setting that we're using will be updated. Now, changing those settings requires you to save the tow file, and it's not something that you're going to see in a Git commit, and it's not going to be something that you can diff. Dirtying the tow file means that if you're collaborating with other developers, then you might have a merge conflict if they did the same thing. So it's not something that I like to do too much, but for the purposes of a tiny little application like this, it's going to have a single user at a time. It's fine. Start timer, what does it do? Well, it says to the log, I'm going to start the timer. It sets the length, hits the init, and hits the start on a timer chop, the only one in the application. And here we go into state. Here's this one timer chop. What it does is it tells state, parent, I could say opt.state, or in this case, it's just the parent. Tell state, the timer's done. That's it. The timer has no idea how the program works. And that's by design. There is a little something hidden in here, and that's timer done. That's it though, because I can assume that something fired on the callback of this timer because something happens when the timer finishes. What happens is timer done. If I go back into a state here, timer done then goes, well, if I'm in this state, then I go to this state. If I'm in this state, then I go to this state. If I'm in this state, then I go, that's it. And then this, of course, goes back up to the top where all of my business logic happens. This is the whole program. I can write this program like this on my phone. I can write the program. It's basically pseudocode. I can write the whole program in a human legible way, and I don't care how it gets implemented. I could go stub out all of these functions in these other classes and just put print statements on them. And then I can go debug the business logic, the application flow of my program, simply by nudging around state, just firing state into different states and making sure that the application flow happens and that the things that I expect to happen in the right order. I can then go in and implement the actual mechanics of the thing with the knowledge that my application is basically done already. All I need to do is put the parts together. That's it though. The implementation of how each of these things works is not really that important. You can see there's not that much Python code. There's another timer. I want to show you why. I just got caught. There's another timer in here. I just want to show you why. There's one more timer, and that's in the countdown. This timer is strictly used. It doesn't even have a callback. It doesn't do anything. It's strictly being used to drive this little thing that actually shows the numbers 3, 2, 1, go. That's all. So there is one more timer in the application, but it doesn't have to be a timer. I'm not really using it as I'm using it as a timer, but it's not a logic timer. It's just a 3, 2, 1, go timer. So let's add the ability to drive application state with some kind of external input. Because currently there's no UI at all for this thing. As an input thing, I would say, let's do like a keyboard input, and we're gonna call it key. And I'm gonna add an extension. The extension is going to be called keyExt because that's what it should be called. I'm going to go in and I'm going to save my extension as keyExt, save contents. There we go. I'm going to go into my dat folder. It's called keyExt. I'm going to save it here. I'm going to make sure that I'm loading it from disk. I would recommend you externalize pretty much all of your code immediately. And then when you edit it in an external editor, you're actually working on the only version of that code that exists. So here's our key extension. I'm just going to do my usual cleanup here. I'm just going to get rid of everything that I don't need. Oh my goodness, look at this. If you have a consistent house style, AI editors can help you out so much. Between having a consistent house style and using types, which we'll get into in another video probably, you get so much out of these AI code assistants in terms of handling boilerplate for you. So I'm gonna drop down a key. Actually, I'm just gonna use a keyboard in dat. And again, this is me using an operator as sparingly as I can possibly use an operator. I'm gonna go in here and I'm gonna say, boom, on key press, keyinfo.key. So we go over here, I press a key. How do you like that? Now, I'm not only firing the key on key down, so that's something that I might want to do. So let's go back into our temporary buffer here, which is still connected. And I want to actually say if keyinfo.state, good. All right, so I'm not gonna just pass the key if it's down. I'm also gonna say and keyinfo dot left control and keyinfo, yeah, left shift. I'm gonna say control shift is the thing that I usually do here. So now if I hit F, nothing happens, but if I hit left control, left shift, F, there you go. So now I can go into my key extension, and when in key extension I get my key here, I'm logging that I've got this key, I can now make these mappings. And I'm thinking about how far I want to take this right now, because there's a whole clever thing that I like to do where I build a little table here and I would map like F to a function like op state blah blah blah. I don't want to get too far into that right now because it's just a quick demonstration of like application architecture stuff. I'm not gonna like give away all my tricks. No, wait, we're gonna say G, I think is what we're gonna do for like go or whatever. We're gonna say op state go. Now you might want to throw the key to the state and let state decide. That's a reasonable thing to do, but we're gonna do key mappings in here because keyboard things are gonna drive the application directly. So now I think if I go into my present over here and I hit shift left control G, away we go. You know what I mean? It's almost like I know what I'm doing. I want to use pi transitions to do this stuff. because I want more fully featured state machine shenanigans in my application. What do I mean by fully featured state machine shenanigans? Well, I'm glad you asked. I want to show you what PyTransitions is capable of right up front to show you an example of like why we might want to do this. First of all, PyTransitions gives you the ability to control application flow in a very granular way by dictating which transitions are valid, which state you can go to from which other state, which are invalid, and what happens when you go from a state to a state. The way these transitions are added here is the arguments to add transition are the name of the transition, the way you fire the transition, and the before state, the after state, and then if you want, methods that will fire, callbacks that will fire before or after or in a couple other places during that transition. So you have really granular control over how you set up for, execute, and clean up from transitions. In a more sophisticated application like a game, that kind of control can be really important to make sure that things happen in the right sequence. You also have the ability to say, if I get a distress call, this is a superhero state machine, if I get a distress call, no matter what I'm doing, the asterisk means from any state, I transition to the state saving the world. That's one really nice thing about this. It's a really batteries included state machine library that can generate mermaid diagrams for you. I think this is called a mermaid diagram. And it has even more detailed, granular definitions for these type of things. This one is the game Twister that I'm working on for Third Wave Arcade. Here I'm using PyTransitions to drive a game. And you can see that when we first start up, we go from startup to standby. If we call intro game, we go from standby to the introduction. We call begin play, we go from intro to playing. And after that, we run after begin play to do a little bit more setup, etc., etc. So this is, again, like the table of contents for what you can do with my game, aside from actually play the game in the playing state. You can do all of these things at the business logic side, and you can do no others. These are the only valid things that you can do. The only thing that's kind of exceptional is, and this is just for dev purposes, is that you can hard reset from any state to standby. And I just have that in there because I get stuck in states fairly frequently as I'm developing the game, because I save an extension and it wipes out its own state and I need to reset and get up to the top and everything like that. Furthermore, with PyTransitions, you have the capability to add generic startups that fire every time you change states. So you can have an after state change method that fires every time you change states. You can have a prepare event that fires every time before an event fires. You can have a finalize event that fires every time, etc. Those can be really helpful for debugging, because if you, for example, are getting into a situation where you're jumping from state to state and you don't really understand why, this can really help you out. So I think I have a method in here called after state change. Let's find it. I set the current state name, which is a member method of my state extension, to get state. So I'm actually not even trusting that I know what I'm in right now. I check my own state and store that state. You can see that I have after intro game implemented. Like after we hard reset, I stop the music. I do that because it makes me insane to be developing while the music is looping from this game. After I introduce the game, I clear the level text. Each of these things, again, it reads like a table of contents. It's very explicit when these things happen. It's just instead of that switch case thing that I was doing in my hand-built state machine, in this one I'm using PyTransitions for all this granular control I have over when things happen and what's allowed. Anyway, we're done. I think I've armed you with what you need to know in order to do this. I'm going to leave it as an exercise to you, dear viewer, to build your own state machine with PyTransitions. I don't want to jinx it, but we might have some really big news soon, and if we do, I can start showing you what we're working on in more detail. It feels good. And if we are, then we're going to immediately start looking at how we're building all these games, and we'll get to that markerless motion capture episode, but I'll be able to like immediately start diving into like us getting a space and us building physical, like a cube, and on all the other games that we're building, because it's not just one game anymore. There's so much going on. I can't wait to share it with you. If I have terrible news about that, which might happen too, I might tell you that too. I just want to be honest with you. I don't want to jinx it. I want to thank Schnoodle Video for the killer editing on these that make them what they are. And I also want to thank the great Breakmaster Cylinder for the music. He's contributed to this and every other project I've done for the last decade. I love you. Goodbye. Hey, it's me and I'm back. I have a longer beard now. Did you like this video? If you did, would you like, would you subscribe? Would you tell a friend? Also, is this how you're building applications in TouchDesigner? I know it isn't. A bunch of you sending me the loads of nodes. I get the loads of nodes all the time. I'm like, what is this spaghetti? It's a mess. Did you learn something? Will you build apps like this? Leave a comment, let me know. There's a lot of brilliant TouchDesigner developers that I greatly respect that disagree with me on a lot of what I've said here, and I encourage them to leave a comment too, but I probably won't read it. It's distasteful to me. Thanks for watching. I'll see you on the next one.